Okay, I'm going to make a separate video for just kind of a warm up to 4.2. In case you're a bit rough on your factoring skills, you can watch this whole video, and I'm going to put it separately in case you feel pretty confident with your factoring, then you can skip this video. So we're going to actually walk through these 10 examples, and we're going to go through full solutions on how to factor them. Once again, if you were feeling great from the review sheet yesterday, then you can probably skip this video and go to the hard ones, the extending. But otherwise, we have a number of different factoring techniques, and we need to kind of remember them all. And we're talking about factoring trinomials in general, so factoring quadratics with an x squared term. So we're going to be learning about, I have little symbols for all of them. PS I call the product sum method. That is when you have three terms, and the first term has just an x squared, so that's an a equals 1. So that's kind of our simple trinomial. You probably called it last year. So I call that the product sum method. There's also a difference of squares, DOS method, and that's when you only have two terms and there's a subtract between them. And there's some other conditions there. There's the perfect square. So there's the perfect square. I think, I forget what my symbol was for that one, maybe PS, but that looks like that one then, product sum method. So perfect square is a special case. We talked about that one quite a bit when we were doing the complete the square questions. We had to manipulate all of them to turn into perfect squares. So that's really the advantage of being able to see a perfect square, was to get you ready for the complete the square questions. Otherwise, they don't actually come up all that often. And when they do come up, most people don't notice them anyway, and you can actually solve them using the PS method or using the other one, which is decomp. So then the other one is, I'm trying to find an example of it. It's probably going to be like down here. If you have an a value that's not going to go away, this is definitely going to be one of them. That's going to be the supreme method, we kind of call it, which is decomp. So maybe I don't have symbols for all of them. I got to invent symbols for these ones. Maybe this one I should just do a squared symbol. Maybe I'll do like a blank squared, perfect square, and decomp. Maybe I don't know what I get called that one. Just a big D. Big D for decomp. There is some kind of other versions like factor by grouping, but that's really just a part of decomposition method. Factoring by grouping doesn't often come up on its own, and if it did, it would probably be more of the grade 12 curriculum. So these four, if we know these ones, then we're going to be pretty good. This is really a very common one when a is 1, so our simple trinomial one. And then this is the one that works on everything. All of these other methods you can actually always do with decomposition. It's a little bit weird with difference of squares, but decomposition works all the time. It just also happens to be the slowest way, so the other ones are short forms. Okay, so let's try some of these. So 3 terms. First thing you always want to do, GCF. I didn't put GCF up here. GCF is a little bit different. That's our greatest common factor, and you always do this one first. So every time you look at any question ever and it says to completely factor it, always try to common factor it first. That should always be your first step. So 3 terms. Can I common factor? Well, there's nothing in the first term, so there's nothing you can common factor. There's going to be no number you can common factor, and there's no x in the last term, so there's no x you can common factor. So this one's just a simple trinomial. It's going to be a product sum method. Product sum method. So I'm looking for 2 numbers that add to my b value, which is -9, and they have to multiply to, you can think of it like a times c, but if it's a simple, it's really just c. So they have to multiply to 18. I can't see what the numbers are right away, so I'm actually going to write these things down. 1 and 18, 2 and 9, 3 and 6. And they're either both positive or both negative. And they have to get to -9. That should be these last 2 then. I think this part right here, this is really something that if you're still doing the first 20 or 30 or 40 factoring questions, you might be really slow with this. And if you haven't done enough and you get to the test, you're going to be really slow with this. You need to get up there. You need to do a lot of factoring questions. You should be getting up 50, 60, 80, 100. Definitely if you're including like grade 10. In this question alone, in this unit alone, you're going to have to do a lot of factoring questions. You need to get really comfortable. Once you get really good, once you get into grade 12, this should take you less than a minute. You should be able to really quickly tell you it's a product sum, find your two numbers, less than a minute. And then since it's a simple one, you can actually jump right to your answer. So your answer, if it's the simple one, it starts with x's. There's no x squareds. It actually breaks down to just single x's because when they multiply, that produces the x squared. So single x, and then your two numbers go in the back. So -3 in one of them and -6 in the other one. And that's it for that one. That really should be a minute or less than a minute question. Eventually. Not right away. At the beginning, you might want to take your time, but then eventually you can become faster and faster. And you might not even have to write down all the numbers eventually. Okay, number 2. Again, trinomial. No a value, can't common factor. So this is, again, is a simple one. So product sum. That's a simple trinomial. So adds to 1, multiplies to -56. I'm going to start telling you kind of tricks. If it has to add to 1, so our two numbers need to be really, really close to each other. Let me get my calculator here. 1's actually a fairly common thing that it has to add to, which means your two numbers need to be 1 apart from each other. So it's going to be very, very close to. A trick I like to do is find what the square root of 56 is. So square root of 56 is equal to 7.48. Because the square root is two numbers that are the exact same that multiply to 56. So two numbers that are only 1 apart look like they're going to be 7 times 8. Why don't we just try that? 7 times 8 is indeed 56. So my two numbers are going to be 7 and 8. One of them is going to be negative, and since it has to add to +1, the bigger one is positive. So -7, +8. So you could have wasted a lot of time looking through all the numbers of 56. It might not be a lot of time actually, but there are kind of fast ways that you can get to this as well. So really quickly, two terms, t minus 7, t plus 8. Okay, number 3. So it's not a simple one, at least at the start, but remember the first thing you want to do is common factor, and all these terms divide by 5. So we are actually going to common factor out 5. That leaves a squared, that leaves minus a, and that leaves 30 divided by 5, which is 6 minus -6. Okay, so that's factored, but that's not completely factored. Now we need to factor what's on the inside. Sorry. So again, simple, adds to -1, multiplies to -6. Once again, we have one of our 1 numbers, just like last time. This time it's pretty easy to find, though. It's 2 and 3. And this time 3 is the -1, because it has to add to -1. So write still the 5. I should have equals everywhere. And then we need a pair of brackets now. A plus 2, a minus 3. So there's 3 examples in a row of product sum method. This one just happened to have a common factor first as well. Let's keep going. Okay, again we have an a value. So this is not a product sum method unless we can common factor it out, but these other ones don't divide by 3. So now it isn't a simple one. Simple was when a is 1, not the variable a, the value a, the coefficient of the x squared term is 1. In this case it's not, so now we have to do a decomp. Guess I lied, I was going to do just capital D. So we need to do decomposition method. It starts out almost the same. Adds 2, multiplies 2. Adds to -11. Some people do P and S instead, but whatever you're comfortable with. Multiplies to 3 times -4, -12. This is the other really easy one to tell. When you get two numbers that are really, really close to each other, it's probably going to be the we call this the trivial product actually. The trivial product is 1 times itself. 1 and 12. 1 times 12 makes 12. So that becomes one number different than 12, right? So one of them has to be negative, and the bigger one is negative. It's actually 1 and negative 12. So if you ever see 1 or a number really, really close, one number off of your number, it's either the number's really, really far or the number's really, really close. So hopefully you can kind of see those ones quick. Now, decomposition means our two magic numbers, that's not our solution. We have to decompose the middle term. So instead of negative 11n's, we have positive 1n, and we have negative 12n. And those immediately would simplify right back to negative 11. They would just go right back to that. But we want them separate because they're going to serve a purpose for us. And the purpose they're going to serve is we now want to group these. So you group the first two terms. I need to group these last two terms, but I don't want to leave the negative on the outside. That's actually really important. It's a common mistake. I want to group the negative with it, but I also don't want to say it's multiplying because it was adding and subtracting before. So I change it to add. So these brackets didn't change the question. It's still just a row of terms. I'm just looking at them like there's two terms at the front and two terms at the back. Now I need to common factor. Out of the first two terms, you can always pull the variable. So I'm going to pull an n. Can I pull any numbers? No. So I just pull an n out of the first ones. So that leaves 3n plus 1. To find what's left behind, just take everything and divide it by that. Take some practice. 3n squared divided by n means just 3n. One of the n's disappears. 1n divided by n is just 1. Out of this one, I'm going to pull a negative. I'm going to pull a 4, and there's no variable this time. So I'm going to pull negative 4 this time. That leaves 3n, and that leaves plus 1. Don't forget to change your signs when you're pulling the negative. And you do have to, the negative can be a little bit tricky to figure out. You need to make it look like the first set of brackets. So if the first term is positive in this one, you need to pull the negative to make it positive in this one as well. Sometimes that can be a little bit tricky, but usually you want the first term to be positive every time. That's a good kind of rule of thumb to make them look the same. Because you could have written plus 4, negative 3n minus 1. That could have been the other way. Anyway, now I have actually two terms. I'm going to go nice and slowly because this is a little bit weird. Actually, a term is separated by plus and minus. So this whole thing in the front is all multiplication, is the way we want to see it. But it's separated by plus and minus here, and then there's a second whole term back here. Now, common factoring means you're pulling a number that's present in both terms to the front. Now, there's nothing with the front terms. N and 4, there's nothing common that I can pull out of those ones. But this whole back thing is actually common to both terms. So I want to pull 3n plus 1 out of each term. So that actually comes to the front. 3n plus 1. Now what did I leave behind still in the first term was 1n. And in the second term I still have a minus 4 left behind. And it's going to look like that every time, and then you're done. So that's decomposition. That's our supreme method. We like that. Okay, number 5. We have a 2, so it's not product sum unless we can common factor it. It does pull out a 30, but it doesn't pull out a 17. And we're not going to actually manipulate things to get decimals. We want everything to be whole numbers in this. Factoring, we don't go into decimals. If we're going into decimals, it's not going to be a pretty factor. We just don't do that. So I cannot common factor. So this is, again, a decomposition. So adds 2, negative 17, multiplies to 2 times 30 is 60. Now, this number isn't close to 60, and it's not close to 1, so it's going to be somewhere like halfway down our list, and I don't have any trick for this one. I'm just going to have to list them all. So I just go up the number line. So 1 times 60, 2 times 30, 3 times 20, 4, does 60 divide by 4? Sometimes I have to check. I don't have the best mental math. 40, 60 divided by 4 is 15. What about 5? Yeah, it's going to divide by 5. That's going to be 12, I believe. 6 and 10. Ooh, a lot of numbers. This is actually probably the most you might see. Most terms only have like 2 or 3 different factors. This is a lot. It doesn't divide by 7, does it? Or 8? 60 divided by 7? No. 60 divided by 8? No. 9, it's not going to happen. And when you get to 10, you've repeated yourself. 10 will be 6. So you don't have to go any further. So a lot to check. They're either both positive or both negative. And since we're trying to get to a negative number, we actually need 2 negatives that get to negative 17. So what actually adds to positive 17? That's those guys. If they're both negative, we get to negative 17. So decomposition, break down your negative 17 into negative 5x and negative 12x. Don't forget the x. There is an x with both terms, not just one of them. It's both, because that makes them common, so they can actually add up to negative 17 of them. Add your 2x squared at the front, add your 30 at the back, and group. Again, I need to group in the negative and change it to positive in between. So that actually happens pretty often, so you gotta make sure you're careful with that. In the front, no numbers common factor, an x does. So I leave behind 2x minus 5. In the back, well, I want to pull out the negative because I want to turn the first term positive. And it looks like I'm going to be pulling out 6. I think both these numbers divide by 6. That looks to be the biggest number. So I'm going to pull out negative 6. If you don't pull out the negative, it's not going to work because it's not going to look the same as this first bracket. So that leaves behind 2x minus 5. It is minus because 30 divided by negative 6 makes negative 5. Common factor. So we have, actually a lot of people actually switch the order at this point because it's easy to just to pull out the 2 things that are by themselves. That might actually be more common. So they say the x minus 6 is kind of by itself, and the 2x minus 5 was our thing in the brackets. Equals, 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 fully factored. A little bit tricky. I didn't really talk much about greatest common factor. If you're struggling with greatest common factors, you really need to come in at a lunchtime or on one of your free periods when I'm also free. Greatest common factor is very important to every single method. It's always what you're doing first. I'm just assuming you're fairly comfortable with it. So if you're rough with greatest common factor, please come see me. Okay, a couple trickier ones. This one is going to be more like a 20-1 type question. So we have a quarter x squared, a half x minus 6. So this is a trinomial. This looks like it's going to be a decomposition, but there's actually a way you can manipulate this. Sometimes when we have numbers that we don't like, we can actually pull them out to the front and make everything bigger. And that's the case here. So this is actually a manipulation thing. It's not really a common factor, but we're going to manipulate it by pulling a quarter out. And then you divide everything by a quarter, which actually means you make everything 4 times bigger. So in the first term, the quarter disappears, so it's now just x squared. If I multiply this by 4, because remember, dividing by a quarter means kiss and flip. It's the same as multiplying by 4. So 4 divided by 2 means 2x. Negative 6 times 4, 6, 12, 18, 24. Negative 24. So it's a nice little trick. We got rid of our fraction, and now we have a simple trinomial. So now this is a product sum method. So adds 2, multiplies 2, adds to positive 2, multiplies to negative 24. I know they have to be 2 apart, so I'm looking fairly far down this list. So does this divide by 6, maybe? 6 and 4? 4 and 6. Yeah, so that should be my 2 numbers. And they have to be, one of them's negative, and the smaller one has to be negative to add to positive 2. If you need to draw the whole list, draw the whole list. but hopefully you can start getting faster eventually. So, simple trinomial, so these are just my answers. 1/4 x minus 4, x plus 6. I often call them my magic numbers, actually. Whatever these two things are my magic numbers, is what my term I like to use. So remember the quarter in the front. A lot of people also forget about the quarter. Once they pull out the quarter, they say, I don't care about it anymore. But it should still be at the front. And then everything else just becomes 2 more brackets. So it's actually 3 sets of multiplication. This guy, we now have some decimals. That's pretty weird, right? How do we do this one? Let me think. We could pull out 0.5. I don't know if that's going to help because that will still leave this one as a decimal. So maybe we just want to try and do decomposition with it. Let's see if we can just do decomposition. So big D. Has to add to negative 5.4. Has to multiply to 4 times 0.5 is equal to 2. That's pretty weird. So that doesn't seem to work. We don't like decimals. How can I find 2 numbers that add to negative 5.4 and still multiply to 2? So it doesn't really work. So we need to actually get rid of these decimals somehow. How are we going to do that? Can we, if we pull out a half, it'll make everything twice as big. That's not going to be enough. We might want to write this as fractions. This really is going to be a 20-1 kind of question. So this is like a half, and this is like a fifth, or it's 2/5. 2/5. It's actually 5 2/5. So we need to clear the fractions. So we're actually going to pull out a 10th. That's going to be the common denominator. If I pull out a 10th, then I make everything 10 times bigger, then there should be no more fractions. Fifth won't work. A half's not going to work. So I'm going to pull out a 10th, or 0.1. So multiply everything by 10. So this should be 5z squared. And if I multiply this by 10, it's negative 54. And then multiply this by 10 plus 40. You can find out if you pulled out too much, if you can actually common factor a number still out. Then you can actually shrink this and shrink that. But it doesn't all divide by 2. It doesn't all divide by 5. So I think that's actually as far as it goes. So let's try it with these 2 numbers now. So it has to add to negative 54. And it has to multiply to 5 times 40. That's going to be 200. So, big numbers, not an easy one to do. This is really kind of the hard question. Let me circle this one. This one's kind of hard. This one's pretty hard. This would be a challenging product sum method. All the factors of 200. Well, there's 1 and 200. There's 2 and 100. 3, I don't think so. 4 should be 50, right? 4 50s make 200. 5 should divide by 5. What is that? Is 40. 6, I'm not sure. If it doesn't divide by 3, it won't divide by 6. But you can always check in your calculator. 200 divided by 6 is 33 point something, so no. 7, I don't think so. What about 8? Yep, 8 and 25. 9, I don't think so, but 10 should. 10 and 20. And that's probably going to be it. There might be like a 12 or something, but let's see if we have enough. So they're either both positive or both negative, going to a negative number, so they both have to be negative. So 2 numbers that add to 54. 50 and 4, right there. If they were both negative. Okay? Try and do this one on your own. You're going to break down the middle term. You're going to group. And then you should end up with a final answer of 1/10 5z minus 4, z minus 10. You should try that one. I'm just kind of running out of room. You might need to get some scrap paper to try that one. But I think finding the numbers, rearranging the formula and finding the numbers were probably the hard part. Once you break it down and then just factor by grouping, that part isn't actually too bad, as long as you know how to greatest common factor. Okay, last 3 questions. There's something very different about these last 3, and what it is you just count. Hey, there's only 2 terms this time. Only 2 terms this time, only 2 terms this time, and that's a dead giveaway that these are DOSes. DOS, DOS, DOS. I don't know they're DOSes, I'm guessing they're DOSes. A DOS is a difference of squares. Difference of squares always involves 2 terms, and there always has to be, it's a difference, so it always has to be a minus in the middle. So this looks like it's going to be DOS. There's actually 3 things you want to check. 1, is there only 2 terms? Yep, yep, yep. 2, is it subtract in the middle? Yep, yep, yep. And then 3, can I take the square root of both sides? Does it make sense to do that? So that wouldn't work if there's a single x term. You cannot take the square root of a single x term. You'll end up with root of x, which we don't like. But this has an x squared, so it either should have it like squared or to the 4th or no variable at all. So this one's a squared, this one's a squared. These numbers look like you can square root them. Same thing here, same thing here, same thing here, same thing here. So all these are going to be DOSes. Now DOS is actually really easy. The hard part is identifying when it is a DOS question. But once you've identified it, all it is I kind of need scrap paper here. Let's see if I get some. So when you have DOS and you have some kind of A term minus some kind of B term, you're going to have something like that. And you know it's a DOS, so you can take the square root of each of them. The answer is actually really easy. You just write 2 brackets, and in the front of both brackets, you're going to write whatever the square root of the leading term is. What is the square root of whatever was at the front, both times? At the back, it's the square root of whatever was the back term. Okay, not too bad so far. And then in the middle, you actually change the sign. 1 plus and 1 minus. And that's all you have to do. So there's not a whole lot of algebra. All the work is in identifying that it is a DOS question. Once you've done that, then you just have to figure out what the square roots are, which a lot of the time is pretty easy. Some of these questions are a little bit challenging, but most of the time it's pretty easy. They actually start right away with a fairly challenging one. Let's do one really easy one, just because they start right away with a medium one. A really easy DOS would look like this, like x squared minus 9. Okay, so we have 2 terms, check. It's a subtract, check. I can take the square root of this, yes, and I can take the square root of this, yes. So this is a DOS, so you write 2 brackets. The square root of x squared is just x. Square root of 9 is 3, and you change the signs, and that's it. So that's an easy one, and these actually come up fairly often. A really, really common one, which a lot of people kind of miss, is this. It looks like it's already pretty simple, so a lot of people think they can't factor it. But you can take the square root of 1. It's just 1. So this one actually does break down into x at the front and 1 at the back. And it actually is a plus and a minus. So this is actually really, really, really common on tests, and a lot of people miss it. I see this on grade 11 exams often as well, and this is one of those things where they think they've fully factored when they have something like this, but it actually breaks down further, and they miss it. So don't be tricked by that one. It is fairly simple, but it does take you noticing it. Okay, let's try some medium ones. Let's assume it's DOS. So let's write 2 brackets. What's the square root of the front? That's actually the square root of each part. So square root of 9 is 3, square root of x squared is x. So it's 3x at the front. Now at the back, what's square root of 0.25? Hopefully you're saying, Mr. Stevens, we're not supposed to have decimals. This is supposed to be with whole numbers. We're not really supposed to have these kind of decimal things. Sometimes we do. And you could put it right in. What is root of 0.25? And the answer is 0.5. Or you could think of it like a fraction. 0.25 is like a quarter, and the square root of a quarter is a half. It actually kind of goes backwards. That's a little bit hard to see. 20-1s, you should be able to see that. You might want to turn this into a fraction. Even if you get it as a decimal, sometimes it's better to put it back as a fraction. But anyway, let's do it with decimals. This is a bit abnormal. So 0.5, square root of y squared as well, which is just y. So 0.5y. And change the sign, plus minus. Okay, I'm going to try and go a bit faster with these last two. DOS, 2 brackets, a quarter. Hey, this is the same thing. The square root of a quarter is a half. D. 1/2 D. Square root of the back. It's actually the square root of the top and square root of the bottom, so it should be 1/7. Square root of A over B is the same as the square root of A over the square root of B. So you can take the root of both ones separately. So root of 1 is just 1, root of 49 is 7. So 1/7 F. 1/7 F plus minus done. Everybody likes DOS. So you really don't want to have to do this with decomposition. You can do it with decomposition, but the numbers, where's our decompositions? You'd have to find 2 different numbers. And the middle term in this one, it actually has to add to 0. So you're actually looking for 2 numbers that add to 0, which makes sense because your 2 numbers end up being like positive 0.5 and negative 0.5. So it's the same number, just positive and negative. So you can do it with decomposition, but it's really annoying. DOS is pretty easy to notice. 2 brackets. Root of 8? Oh, that one doesn't work. Common factor first. Always remember to common factor first. So first I'm going to pull out, I can pull out 2. Can I pull out, that'll make that 9. So I can't pull out 4. I can't pull out 8. I'm going to pull out a 2. That leaves behind 4a squared minus 9b squared. And that's much better. So we still have a 2 at the front. Now it's 2a and 3b. Plus, minus, done. Okay. If you're still struggling with some of these methods, we didn't do any perfect square ones. Outside of completing the square, most people forget about this, and most people end up doing it with either product sum or decomposition. So this one really isn't that common. It is faster if you can notice it, but the test is weird. So I'm not actually going to teach that one right now. But hopefully you're familiar with these other ones now. If you need extra help on any of these things, or if you don't remember how to greatest common factor very well, please, you're going to have to come see me at lunch. And please do so, because factoring is a major part of this unit. If you don't remember how to factor, you're going to be in a lot of trouble when we get to the test. Most of this should be grade 10 knowledge, but some of this is already getting harder than grade 10. Like most of these ones, this guy, maybe mostly those two are kind of harder than what you would see in grade 10 probably. The rest of those you probably should have seen in grade 10. Okay, that's it for this lesson. You'll have to go click on my other video and we'll start the actual 4.2 there.